Introducing Nose to Tail, a podcast where we explore the world of aviation lifecycle solutions, insights, and more. Presented by Jet Midwest.
Welcome back to the Nose to Tail podcast. I'm Patrick Kraus, COO of Jet Midwest. I'm here with Manny from Fortek. Manny, how you doing?
Fantastic. Pleasure.
I know all of our fans out there are excited to hear what your history is about and how your career's progressed in aviation. So why don't we start with your origin story, kind of how you got into the business and what made you excited about aviation?
Yeah, absolutely. So with me, I started in a summer internship, 2015. It was with Fortek Aviation repairs down in Miami. And I was a customer service representative and shipping and receiving clerk. And so that's what sparked my initial interest in aviation, the pace, and that's what really intrigued me. And ever since I did that internship at Fortek, I've always been trying to come back to aviation. I went to school after that. I did some internships at Rockwell Collins and Northrop Grumman and Ford Motors, interestingly enough, and I did some research in nuclear waste robotics. And that really gave me all the confidence and expertise I needed to go into the avionics field, to get into avionics where I am now.
So you went to Florida International.
Yes.
And then what degree did you get?
Electrical engineering, yeah.
So you went from Aerotech being a customer service rep, and then it sounds like you had some really neat exposure. I think we had talked about, you'd mentioned you built robots to manage nuclear waste.
So at the university, there was a program with the Department of Energy. And so what they needed from the university and the research staff was disposable robotics so that they can send into their nuclear waste chambers and not have to worry about an expensive robot getting burnt by the nuclear waste. They could send in these disposable ones that were 3D printed, and then the electronics were really cheap. So they could send it in to do visual inspections of the caverns and not have to worry about cost. And so that was the kind of work I did as a researcher at Florida International.
That sounds like fun. Did you get to see the results, like, actually seeing those go into production and those actually go into the field?
Yes.
That's pretty neat. What was the most exciting part about working on a project like that?
Well, just the people, the knowledge, and the tremendous amount of knowledge that they had. I got up excited every day because I said, what am I going to learn today?
Yeah. You also mentioned Northrop, and I know I kind of preloaded this question for you because I was super confused. So at Northrop Grumman, you were a digital communications engineer. So help us understand maybe what that really means.
So when I got out of college, I got hired by Northrop Grumman. I worked in their depot repairing digital electronics. So anything that went bad in the field, they would send it into the depot, and then we would diagnose, troubleshoot, and repair it. And then later, the next job I did with them was validation of new designs for digital electronics. And so the difference between digital electronics and analog electronics is just basically that the signals get sampled in digital electronics. Most of the communication, the waves traveling to the satellites in space that give us the internet and everything, they're analog waves, and then they get sampled up there, processed. And so once they get sampled, then they become digital, and you need digital circuitry behind it to analyze that data. And so basically what I was doing is making sure that those digital circuits were meeting the specifications that they were supposed to. And if not, there was a feedback loop to help remedy that.
So was that a bit of a blend of older technologies into more modern technology?
That one was purely modern technology. All that work was purely modern technology. Well, at first, when I worked at the depot, it was some legacy technology. But I deal with a lot of legacy technology now at Fortek because we do a lot of work on the 737s, Classic and NG. And the electronics I see come into the shop, it's something that I would read about in a college textbook. Like, this is the way things used to be. I got to learn about it in college as if it were like a history lesson, but now I get to actually see it.
All right, so that does tell us a couple of things about the whole aviation industry of itself. And I think it's both a blessing and a curse, right? I think that things move very slowly from a regulatory standpoint. So what gets designed in 1990 doesn't actually make aboard an airplane for till 2000, right? And by then, it's already superseded by some other technology. But in order to keep the aircraft safe, to make sure we've checked every single box along the way for a decade, but there's a little bit of comedy in that you're being taught historical technologies, and 15 years later, that's your expertise.
Yeah, I mean it's interesting because it's so my dad's an electrical engineer and he got his degree way before me, so he saw it all happen. And the beauty of it is that the old technology is the basis for the new technology, you know. And a lot of new engineers have trouble because when they go into any industry, they're going from 0 to 100.
From a takeaway standpoint, what are the maybe top 3 items that you had a takeaway from those college internships and then that first run at Northrop that you're able to apply to your job at Fortek?
As far as, like developing new capes, establishing equivalences between what the OEM says and things that we can build and have in our shop, it's the analytical mindset and reading technical documentations. I read through a lot of CMMs and can understand them thanks to the fact that I worked as an engineer and I had to read a lot of technical documentations and understand them and think critically about them. That is the biggest thing, is being able to read a CMM and break stuff down in terms of components. So stuff will get sent into a shop and it's a component, and then it'll be composed of subcomponents. And then those subcomponents a lot of times will have standard parts. And the breakdown from top to bottom, not just looking at something as an entity, but breaking it down into its component parts in your mind was a good skill. A lot of repairs get saved just by being able to identify the components of a subcomponent and realizing that they're standard parts, mil-spec parts that can be found in the open market outside of aviation.
Yeah, I think sometimes we take for granted for people out in the marketplace to understand that you say, well, one of the biggest takeaways is I learned how to really understand and read a CMM. It's way more complicated. For all of our listeners who are out there, if you've never seen a CMM or the engineering documents and you have to get in those for the first time, it's a foreign language. It does have a cadence to it. So a lot of people who, like yourself, who get very good at it, have a very good understanding of where they want to look for the information they're getting. So it's a little bit of a reference guide. But there's some flexibility oftentimes built into the CMM where it says, hey, you're troubleshooting, here's where you're going to go with that. And it is a much more difficult task. We work on everything from single components all the way up to whole airplanes, right? And every time my technical team starts talking about getting into the CMM and really digging in and working on it to get the answer, and they look at me and I'm like, don't look at me. That's not my skill set. I'm a people person. And they're the guys that can read that and really understand how to go. So it is, I could see in my team, it is a huge skill. We often tell our young technicians, especially when their experience level is low, as your competence of how to manage a repair coming out of the CMM, you're competent. You can probably manage your way through this, but you probably need help when you get to the end, when you get to this stopping point or confusion. You really need to grab someone who's driven up to a mastery level, because there's a whole lot in between there, and there's a lot to learn, and it does take sometimes a whole bunch of people to make sure that everybody's seeing things the way that it really is being presented. Why don't you talk to me a little bit about really what the expertise is at Fortek? What are you really known for, and what really differentiates you guys from the rest of the marketplace?
The majority of our upper staff is electrical engineers, so they've got a high level of expertise in troubleshooting, diagnosing, and repairing electronics, and that allows us to specialize in not only avionics but electromechanical equipment and galley equipment. Because the electronics in galley equipment sometimes are exposed to water, pressure, and humidity, which is bad for electronics. Having that specialization really helps troubleshoot that aspect, which is the most difficult aspect of a galley repair. And in electromechanics, the blend of electrical and mechanical knowledge is critical because a lot of people have the mechanical, but they don't have the electrical. I have found the knowledge to troubleshoot the electrical system within an actuator. We do a lot of work with the D2070-9s, 11s, and 12s, and D2063s, which is a dual door actuator, and of course then the avionics part of it, where a lot of the times the troubleshooting and the diagnosing, it can be very vague, and so that's where that expertise at the higher level can help save a part or cut down turnaround time, because you're not going out looking at something that's erroneous. You can get to the root cause of a failure. And so to summarize, what we're known for is avionics. That's where we stand out, and electromechanical repairs. We do a lot of work in galley. We get sent those a lot, and it's a really good flow. But I would say that what we're most known for is avionics and electromechanical repairs.
Nice. As part of where your company is going, is that going to be about acquiring more customers, or is that about expanding your capabilities, or maybe a blend of both?
I would say a blend of both. We like a diverse array of customers, and we're looking into expanding into a diverse amount of repairs too. Like we want to do more work on valves. We've gotten over the years more expertise in mechanical and actuation and those sort of things. So I think the next area that we want to delve into is valves, pneumatic valves, and hydraulic valves, and those sorts of components. And we do some lavatory components too. We get a lot of ball drain valves. We do those too, and we're slowly expanding into the lavatory area. Those are the three areas that we're looking into expanding into, and I'm always looking for more customers. I think that, especially with our customer service, we've got a great customer service team. Whenever there's like a high-profile customer, I'll go in directly and deal with them directly, make sure that they are getting exactly what they need. I believe recently there was a large shipment of coffee makers sent from Jet Midwest to us, and we drop shipped it, and I was directly involved in that, in the coordination of that, because I knew it was a very important repair, very big repair that we did for you guys.
Well, I'll tell you, the ability to salvage parts because you have a robust engineering department is a huge piece for the marketplace. You know, a lot of the parts that Jet Midwest sends out will only have routine challenges because, for the most part, our supply chain comes from flying aircraft, right? So we fly an aircraft into Kansas City. Perhaps we're going to put it out to market for sale. So we have that in a storage program, and then maybe after 6 months we go, hey, we have a buyer for the engines. So let's sell the engines, and we'll go ahead and tear down the airplane. So typically the parts that come off, they work, right? And so for a lot of the repairs that we do, they're pretty simple. But then when you get into the critical parts, really those high turn, high volume parts, now we're in a spot where every single unit, no matter what, even if it fails, we're sending it out to get it repaired. We need that top tier of parts on the shelf. And it takes companies like yours to go in and go, hey, yes, this doesn't work. And if you go through the OEM process, this is a $50,000 repair. But because you've got engineering, you guys are saying, hey, we can do something different here, because the OEM is just take that card out and replace it with a new card.
Yeah.
Because they sell cards for a living. And Fortek is selling the engineering in a repair solution.
Absolutely.
We'll continue this discussion on the next episode of Nose to Tail, a podcast presented by Jet Midwest. Don't forget to please like and subscribe to our channel.